Hi, it's Mrs. Moret with a review for the Unit 2 Rational Functions Final Assessment. Just a note that this PowerPoint is available to you as a blank copy. I highly recommend that you use this video as needed to help you complete the review independently. All right, let's get started. So this cylinder has a volume of 10 cubic feet. The surface area of the cylinder can be found using the function where x represents the radius of the cylinder. So we have the function here, and we have to determine which value of x, the radius, will yield a larger surface area. So for A, a radius of 1, or B, a radius of 1.2. Now, it's really tempting to just say, oh, 1.2 because that's a bigger number. But remember, this is a rational function. They don't always work that way. And so you really want to actually maybe look at a graph to determine that. And while we're looking at the graph, we can also determine the values of x for number 2. That will, let's see here, for what value of x will the surface area be the smallest? And what is that surface area? So we can answer both of those questions if we look at this graph in Desmos. So I have it graphed here, and you might take a look at the, excuse me, you might take a look at the axes and how they're numbered so that you might be able to then make a similar graph as needed when you need to. So I also graphed the two options for x equals 1 and x equals 2. And if I put x equals 1 on the screen, I can see this point here where they cross. The surface area is 26.283. And then notice that the function is still a little bit on its way down after that. So when I graph the other, x equals 1.2, it's slightly lower. And it has a surface area, if the radius is 1.2, the surface area is 25.714. So that's actually a smaller surface area than it would be if the radius was 1. So the first answer is x equals 1. X equals 1 has a larger surface area, 26.283, compared to 25.714. To answer the other question, then we need to know the minimum point. So the minimum point here is 1.168. That's the radius. And then that gives us the smallest surface area is 25.695 is the surface area. So the first number there is the x. Lost it. The first number there is the x, and then the second number there is the y. So x represents the radius, and y represents the surface area. All right, so that answers the first questions. On the next one, I'm going to do some work on the screen now. Okay, so we have determined the non-zero vertical and or horizontal asymptotes for each rational function. So the non-zero one. So for A, I have this equation written, and I know that if the denominator of the fraction is equal to 0, we would have an asymptote. So x minus 4 equals 0. Add the 4. And we get x equals 4. If x equals 4 is the asymptote, and that is vertical. For B, I notice that the denominator just has x, and there's an additional x up in the numerator. And so I can split this apart, dividing both terms by x. So 3 divided by x is 3x, or sorry, 3 over x. And then plus 12x divided by x is 12. So this is a horizontal asymptote there. It's y equals 12, and it's horizontal. And the last one, it's already broken apart, so I have the -4 there. So this one is also horizontal, y equals -4. And on the graph, so the horizontal asymptote is, get a yellow pen. The horizontal asymptote is this one, and it's at y equals 1. And the vertical asymptote is this one here, and it's at x equals -1, -2, -3. This is x equals -3. And again, this one was horizontal, can abbreviate HA for horizontal asymptote, and this one is vertical, so VA for vertical asymptote. Okay, the next couple of questions have to do with finding the average cost per item in a situation. So this says the function c of x equals 25 plus 0.3 or 3.85x divided by x models the average cost per item for a clothing company to produce socks that are customized for a sports team. Number one, which value might represent the company's fee to produce an order of socks? So to produce an order of socks, that's going to be like a one-time fee. And so I would say the 25 in the equation is going to be the value that would represent the fee, the one-time fee just to produce the socks. And then number two, which value might represent the supply cost per pair of socks ordered? So per pair of socks ordered, that implies it's going to be multiplied by the number of socks that you order. And so the 3.85 is that value since 3.85 is being multiplied by x. Number three, which team would pay less per pair of socks? A basketball team ordering 10 pairs of socks or a football team ordering 45 pairs of socks? Well, if a team is only ordering 10 pairs of socks, each pair is going to incur the cost of $3.85, but then they're going to break up the production cost only between 10 pairs of socks. However, if they order 45 pairs of socks, then they're going to be splitting up the $25 amongst 45. So the average cost, who would pay less per pair of socks? It would be the football team. The football team would be paying the least because they're ordering more socks. And then number four, as the number of pairs of socks ordered gets very large, maybe a university is ordering their entire athletics program. What value does the average cost per pair of socks approach? And so it's going to be approaching the asymptote. So if we look at this on a graph, I have this graphed as well, we can see the 3.85 is the horizontal asymptote, y equals 3.85. So that's going to be the value that the function approaches as a very large number of socks is ordered. So $3.85. Okay, the last couple of problems here are solving. So we're going to be solving some rational equations. And remember that to solve a rational equation, you always want to eliminate the fractions by multiplying by denominators. So for this first one, I see the 145 plus 9x is being divided by x. So we will start and undo the divide by x by multiplying by x. And so that eliminates this fraction completely. And we have 145 plus 9x equals 4x. The next step then is to move the 9x over using subtraction. And so 145 equals negative 5x. And then our last step is to divide by the negative 5. And let's see here, 145 divided by negative 5 is equal to negative 29. Okay, this new problem, again, we are looking at a fraction on each side of the equation. Our denominators are different, and so we want to eliminate the denominators, eliminate the fractions by multiplying both sides of the equation by both of the denominators. So 6 minus x and 6 plus x. And same thing over here. 6 minus x, 6 plus x. Okay, so on the left side of the equation, we eliminate, oopsies, we eliminate the other. We eliminate the 6 minus x's. And on the right side of the equation, we eliminate the 6 plus x's. So now we have 4 times 6 plus x equals 12 times 6 minus x. And so we should just clean up each side by distributing, and then we can solve. So this is going to be 24 plus 4x by distributing the 4. And then 72 minus 12x by distributing the 12. And then from here, I'm going to do two things. I'm going to add the 12x to both sides, opposite sign, right? I'm going to line it up here under the 4x, but I'm also going to subtract the 24 from each side. Okay, so that way I've eliminated the constants on the left side and the variables on the right side. And so I can add this all up and find my final answer for x. So on the left, 4x plus 12x is 16x. And then 72 minus 24 is equal to 48. And finally, divide by the 16, so you get x by itself. And 48 divided by 16 is 3, so x equals 3. Okay, we can do the same strategy here. We're going to multiply both sides of the equation by both denominators. So times x minus 2 times 3x plus 2, and over here as well, x minus 2 times 3x plus 2. On the left side of the equation, we will eliminate the x minus 2's. I'm going to go ahead and distribute. So 3x plus 2 times 5 is 15x plus 10. And then over here, the 3x plus 2's are eliminated, and we can distribute the 7. 7 times x minus 2 is equal to 7x minus 14. And now I'm going to do the same thing. Move the x's to the left by subtracting the 7x so that this is 0. And then I will also move the constant to the right. So I'm going to subtract the 10 so that this equals 0. And then 15x minus 7x is 8x. And negative 14 minus 10 is negative 24. Divide by the 8, x equals negative 3. And this is our last problem. So I'm going to eliminate the fraction. There's just one fraction this time. And I'm going to do that by multiplying by x plus 3 on both sides. So I have this. And then x plus 2 times x plus 3. I'm going to multiply that out. X plus 2 times x plus 3. This one's a little bit more complicated because I'm going to get a quadratic. X squared, 2 times x is 2x, 3 times x is 3x, and 3 times 2 is 6. All right, so I just simplified this side of the equation. I get x squared plus 5x plus 6, and then that's equal to 2. All right, so again, this is a quadratic. And so to solve a quadratic, I need one side of the equation to equal 0. It's pretty simple to just move the 2 over by subtracting. And so I have x squared plus 5x plus 4 is equal to 0. So I have two options. I could factor, or I could use the quadratic formula. This one's pretty simple to factor because I know that, we're going to look at it this way. We have x squared here and 4 here. So what multiplies to 4x squared and adds to 5x? And that's going to be 4x and 1x. That multiplies to 4x squared. So this part will work. That multiplies to 4x squared, but it also adds to 5x. Okay, so that means I can put a 4x here and a 1x here. And so it factors out. Remember, this is x times x. Need a 1 here and a 4 here. So x plus 1 times x plus 4 is equal to 0. And then I set each factor equal to 0 and solve. So for this one, I subtract the 1 from both sides, x equals negative 1. And for this one, I subtract the 4 from both sides, and x equals negative 4. So those are the two solutions for this last problem. All right, I hope this video was helpful. Just a reminder that you will be required to submit a picture of your work when you take the test this week. And so make sure that you're able to work these problems out. Use the video to help you practice doing the work.